What are mixtures? Today we're going to be taking a look at a specific kind of physical change, and it's called a mixture. So if you remember, this whole chapter 13, is about physical changes, chemical changes, and then properties that describe matter. So we're looking at a specific type of physical change like we began to look at last week, and this is called a mixture. We're going to look at different types of mixtures. And a mixture is a combination of two or more substances that keep their original properties. For example, here are some heterogeneous mixtures. Now, there are both heterogeneous and homogeneous mixtures. Heterogeneous mixtures are unevenly mixed. Homogeneous ones are evenly mixed. So if you look at the cookie, for instance, you have chocolate chips and cookie dough, but they're not evenly mixed. With the sandwich, you have lettuce and tomatoes, some meat, some mayonnaise, but not evenly mixed. Same with the pizza with its toppings and cheese, and the soda with the ice and the salad. There are all these different parts, and the parts don't change when you put them together. I mean, for instance, the tomatoes and the lettuce still say tomatoes and lettuce. They're only mixed together, so they keep their original properties. And with this heterogeneous mixture, they're not mixed evenly. Now, you can't have a homogeneous mixture, which, for example, would be the milk we'll see later. But these are examples of heterogeneous mixtures. And mixtures, again, you can change the amounts of things, the proportions of them, the proportions of their ingredients, but really they're all around us. For instance, like these seashells, if you've ever been to the ocean, you've probably seen different types of seashells mixed with the sand. So take a minute, if you haven't yet, and show what you know. List 3 examples of mixtures in the classroom or outside in nature. Here are a few. One is, if you think of the different types of people, we have boys and we have girls. That's one type of mixture. We have people from Smoketown and Brownstown and Fritz and Leola. That's another type of mixture you could list. If you look outside, you might see the gravel. There are different types of rocks in gravel. Or maybe you think about a glass with ice in it, like we looked at just before. That's another different type of mixture. You could have water and ice. There are many, many more. So you can use some of those, or you can list 3 of your own. Now, you can separate mixtures too, and often we do. It's possible if the materials keep their original properties. So I don't know if you ever thought about pasta and water as a mixture, but you can separate those, and some are easier to separate than others. So let's think, why would someone want to separate the parts of a mixture? One reason they might want to do that is because one part is useful to them and another part isn't. For instance, if you drop some screws into a pile of sawdust in a wood shop, you might need the screws, so you want to get them out, and you don't need the sawdust. Or maybe you are working with Legos. You might want some types of Lego pieces and not other types of Lego pieces. So it all depends on what you're working with and why you need what you need. And another example, again, is if you're eating, you might want some parts of the food you're eating and not others. Like maybe you want to pick the pepperonis off the pizza or the black olives. A solution is one of 3 types of mixtures that deals with the size of the pieces in the mixture, or the particle size. And a solution is a mixture in which all the substances are evenly distributed. For instance, you have a solid and a liquid, and you mix them together, and it looks like one even mix. I can give you an example. This morning, I put some drink mix into my water that helps me stay hydrated, and I mixed it up, and it changed color, but it spread evenly out so that it looked like a solution. And a solution is made up of several parts, which we'll get to in just a minute. But another example of this is salt and water. You can mix them together, or sugar and water. And the salt dissolves in the water. Everything is distributed evenly, the same amount in the liquid. And again, it dissolves in the liquid. So in a solution, the parts are the solute. For instance, salt is an example of one here. The solvent, the water. So you put the solute, the salt, into the solvent, the water, and that gives you a solution, which is salt water. This is a funny word to say, solute. That's the thing you put in. And solvent is the thing that's holding the solute. Show what you know. Which solid do you think has more solubility or can spread out more evenly and dissolve easily? A sugar cube or a Lego? If you guess sugar cube, you're right, because the sugar cube comes apart easily and can be spread out in water, for instance, whereas a Lego has smaller particles and is harder to break down and spread out evenly. The second type of mixture that has to do with particle size is a suspension. And no, this isn't the type that's bad when you need to stay out of school for a couple days. Rather, it's a mixture that contains particles large enough to be seen. So it's bigger particles this time. For instance, if you've ever watered your houseplant, you've probably seen little particles of dirt in the water, and this is a suspension for a while until the dirt settles down at the bottom. Or if you've ever been into a pond or a river after it rains, it might be muddy for a little while, but after a couple of days, all the particles settle to the bottom. And they're big enough that you can see them. You can see the particles here, but it doesn't stay that way forever. The parts settle to the bottom. So what happens to a suspension after it has been sitting for a little bit? The parts settle to the bottom. They separate. The solute goes to the bottom, although it's not really a solute. It's the particles in the suspension, they go to the bottom. Finally, a colloid is a mixture that contains particles that are too small to be seen. An example of this is homogenized milk. If refrigerated, the particles won't separate, and these particles, again, are too small to be seen. So show what you know. Drag and drop each of the salad dressings according to the mixture type. You can actually grab the white boxes here and decide whether the Barcelona vinaigrette or the original ranch, the Hidden Valley Ranch, is the suspension and which one is the colloid.